Hey, everybody, this is Larry. This is March 22nd. I guess it just turned to 22nd. It's like a couple minutes after midnight here in New York. I'm trying to do a random algo problem that I haven't done yet. So let's get to it. Just gotta get myself a little bit more practice. And today's extra problem, bonus problem, Larry's problem is 27-7. Paths in maze that lead to same room. A maze consists of n rooms numbered 1 to n, and some rooms are connected by corridors. You're given 2D integer array corridors where corridor sub I is equal to rooms 1 sub I to rooms 2 sub I, indicating there's a corridor connecting 1 and 2, allowing a person in the maze to go from 1 and 2 and vice versa. The designer of the maze wants to know how confusing it is. The confusion score of the maze is the number of cycles of length 3. Okay. First thing I want to do is check out what the n is. If n is small, then yeah. Because basically, if n is 100, then n cubed is pretty straightforward. But I'm trying to think whether we can do a lazy n square, right? Because we only care about cycles of length 3, right? So basically, we're almost trying to do like a transitive or not. We're trying to figure out whether a transitive property thing exists, right? So basically, for almost like for every a and b, we want to find the intersection of those things, right? And the intersection, but naively that'll be n cubed because so is there a way to do it smarter? Wait, are these oh yeah, it is. Okay, it's because I saw directed graphs or directed edges here, so I was just curious whether I'm like just want to make sure I'm reading things correctly. But okay. Hmm. Alternatively, okay, we look at all the edges of one node, or all the neighbors of one node, and then we see how many of them are connected to each other. Does that make sense? No, but I think all you have to do is like a breadth first search from each node or something. And if you do a naive breadth first search from each node, that'll be v times v plus e. What is e? E can be pretty big. But if we limit it by just having like a distance of 2, then at most we should be just like 2 times v, right? Because you only look at each, because basically the first like for each node, wait, let me double check that that's true. Yeah, there are no duplicate corridors, so for each node at most one distance away is going to be 1,000, and then 2 distance away is that still 1,000? No, I guess maybe not. Well, I mean that'll be but I think that is the idea, right? Because the idea is that okay, you check for 2 distances away. I'm trying to think of if that might. I think the complexity feels a little bit slow, but the idea is that you check something that's 2 distance away, right? Because if you check something 2 distance away, you could see that well everything 2 distance away is 2 distance away, but on the way to that, if your check, like if something that's 1 distance away is also 1 distance away from something that's 1 distance away, then then you have a cycle of length 3, right? I think that's basically the idea is BFS, but that still feels a little bit slow because it can be the entire yi, right? So v times yi feels like it's going to be a little bit slow, right? 1,000, so it's like 5 times 10 to the 7 feels a little bit slow. Oh. Excuse me. I'm trying to think whether that is like what would that tell us? It would tell us all the cycles that are involved with the node that we just BFS off. Okay, that's right. That's true. Sorry, it's very late. I should be already going to bed. But can I make... so what I'm trying to do now is make one more optimization. I think we're a little bit slow. The idea will be okay. Unless I'm misunderstanding some parts of it. But... because it's just a little bit slow to do it on each node. Oh man. Can I do it in one breadth first search or one depth first search? One breadth first search. Probably not. Or at least not all possible ones. Yeah, that does seem like it'll be a little bit slow, so I don't get it. What other things can we use? Right, because basically we have a... because I'm thinking about the worst case, right? I guess it can... I think the thing with this problem is that I think there is some like self-limiting thing that I cannot prove. Because I'm trying to think about what's the worst case in this thing. Because yi in this case, the number of edges is not n squared, which is usually for a complete graph, right? Or n over 2, or n squared over 2 or something like this for symmetry reasons for a directed graph. But I wonder if there's like some self-limiting thing because everything would be one, like because you cannot have a complete graph, you also don't look at all the edges most of the time. Is that true though? Yeah. But I don't know. I'm gonna YOLO this and then we'll see maybe. Yeah, let's play around with it. Because I don't really have any other ideas to be honest. But it is what it is. Yeah. Okay, yeah, let's go. Okay, first we want to change into an adjacency list. Right. Yep. And yeah, and this is kind of one based, one indexed, which I always hate, but yeah, that's fine, I guess. So then now we just do yeah, and then that's it, right? Magic. But yeah, but this is a special buffer search, right? We have a start, we have a deck, and then basically we have yeah. Right. So okay, and then now we go for we in the up now, right? This is regular buffer search stuff, right? So if we not in best, then best we is equal to best of now plus one, q dot append v, right? I mean, this is but we haven't made the modification yet, right? But the idea here is that we want to limit it to 2, right? So okay, so then we really only need to go 1, right? So start is going to be 1 or 0, sorry, and then this is going to, everything else is going to be 1, right? So maybe we can even write this in a different way, right? So basically, for example, we can write for we in year start, for we in year start, we go best of v is equal to 1, just because that's just the way we have it, right? And then q append v, and then we don't append start. We don't, we could do it this way, but yeah. And then now we can say we go through the queue, and it's not even a queue, it's just a check. It's almost like one step of the Floyd Warshaw or something like this, kind of, not really, but yeah. And then here, all right, now is equal to q.pop left, and then all we have to do is check v.now if v is in best and best of v is equal to 1, then that means that there's a start going to now, going to v, so then we can do something like count increment 1, right? And of course, you don't even need a queue, as you can see anymore, but yeah. But this isn't quite right because we kind of have symmetry reasons, so like it goes 1, 2, 3, and then 1, 3, 2, right? So then we have to divide this by 2. But it also double counts the other one, so maybe we could just keep the double count and then just divide it by 3. We'll run it real quick, just to see if we're, collections. I mean, we're wrong, we should be just wrong by a factor of 3 anyway, so we'll just, okay. Well, this is more than factor of 3. Why is there 12? So 1, right. Okay, so 1 is in 4. Why is that? 1, 2, 4, 1, 3, 4. All right, let's print it real quick. Start now v, right? So that's the triplets. So 1, 2, 4, 1, 4, 2, 1, 4, 3, 1, 3, 4. So yeah, so this double counts as we expect. That's fine. Okay. So do I double count? How do I get to? Okay, so I double count on the ordering, and then I have to triple. Okay, so it's over by 6. So actually, it's not quite what we had hoped, but it is kind of what we expected. The reason why it's 6 is because when you have 1, 2, 3, there's 3 combinations of well, it's just 6, 3 factorial 6, so you can think of it that way too. Maybe that's just a cleaner way of saying it. Yeah, let's give it a submit. I don't know if it's too slow, to be honest. That's my concern. I wouldn't be surprised if it is. It is kind of a little bit on the slower side regardless. And I mean, some of it you could actually do a little bit lazier, not lazier, but just like clean up. some of these things so that it doesn't do it 6 times more. But I do wonder if there's a algo that's actually just like much faster. So I'm gonna look real quick. Set in this, really? I mean, I thought well, why is that fast enough? Isn't this n cube? Oh, this TLE is that, okay, that's what I expected. That's what I was saying, but I thought that this intersection is also, I don't know, I think, okay, they're saying it's not TLE, but it's still, yeah, okay. Because I think this one is, maybe this problem is just like a little bit awkward in mind games, because this is obviously too slow, but yeah. And this is just, yeah, I mean, maybe this is intended, but it's still v times z is like the same complexity as mine. I mean, their complexity is cleaner, but it's still like the complexity that I don't know. I didn't think, or I thought it would be too slow, but it's not too difficult. See, when you're a problem, if you write anything, you know, this is a useless statement, right? And I don't know. Sorry, silent rings. I'm just using you as an example. Because this statement tells the user nothing, right? It's literally a filler. All right, erase the 10 seconds of my maybe less. I read faster than that, but then I complain for it for 10 seconds. So, okay, yeah, I might. I guess I thought about. Oh, I think I was trying to do it in one depth of search. I mean, if you do it on, okay, I mean that's, yeah, okay. Yeah, I mean that's pretty much straightforward, but that's also v times z, right? What I'm trying to do is just trying to find something better than v times z, which yeah, okay, this is also v times z. Is it? Maybe I'm wrong. I mean, I don't know. This is very awkward. I mean, it's, yeah. I think maybe complexity wise we're pretty good, but it's just like they are like things that people can do to make it slightly faster, but the complexity is the same, right? So, okay. I mean, I was a little bit lazy. I could have done some of that complexity. I don't know, and I used obviously breadth first search instead of depth first search. But for depth first search, I actually was trying to find. I mentioned a little bit that depth first search won't work, but I was saying that in the context of doing one depth first search. If you do it at depth first search n time, then it's the same as mine, except for, I don't know. I guess I didn't even need to write a depth first search here, right? This is just two folders. I call it breadth first search, but I don't even need a queue. I just need this could be an array, and then I just have an array, and you know. So yeah. So maybe this is what it is. Sometimes Leetcode is mind games. We got the optimal complexity, give or take. So yeah, I'll try out for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.